Now in last class we have done analytical method, and we have found out the tangential stress and the normal stress and resultant stress on a plane which is at an angle with the vertical plane. Now today we will learn the graphical method, which is very easy and interesting, but you have to measure all those quantities with rulers and protractors. Those must be accurate. So now in our last problem we have found out the principal plane and two different stresses. We will solve another angle, another problem. Let me set it up first. Okay, so we will first understand the procedure, which is very interesting. When the procedure is clear, then we go for another problem. Okay, now graphical method means there should be a coordinate system. Here on graphical method, we take a coordinate system where we take tensile stresses are positive, and so compressive stresses are negative, just like the analytical method. And the shear stress just give me a moment, we will directly solve it. Yeah, now the shear stress when clockwise can be taken negative, so counterclockwise can be taken positive. Now you must understand that this is just a assumption. You can take the opposite also. So if you take clockwise as positive and counterclockwise as negative, then there is no problem, and you have to interpret the graph in that way. Okay, we are taking this clockwise as positive or counterclockwise negative. You can take opposite also, that won't be a matter. Okay, now along this x-axis we will take normal stresses. Along this y-axis we will take shear stresses. Okay, now let us have a problem where we have let us draw again the diagram. Let us draw it again. uh, this is a cross section of unit thickness. The names are as such: A, B, C, D. Now the stresses working, are tensile, at both the direction. So this was sigma 2 in previous days uh, problem. Here also we will take the same, so that we can understand. This stress is, sorry, this is sigma 1 and this is sigma 2 and sigma 2. Okay, now there is another shear stress tau along BC and AD. Okay, so we have normal tensile stresses okay, I have a phone call, the video might be disconnected. Okay, stay connected. Okay, so we have normal tensile stresses sigma 1 and sigma 2 as per the figure, and we have shear stress at BC and AD phase of magnitude tau and direction clockwise. Okay, this is a scenario. Now our job is to get the stresses. Stresses means tangential stress, normal stress and resultant stress to be found out at an angle theta with the vertical. So at a plane CF, which is at an angle theta with the BC. Okay, this is our job, to find out sigma r, sigma n, sigma t uh, along CF, normal to CF, and the resultant on CF. Okay, now for that purpose we have drawn the coordinate system here. In this coordinate system, our job is to draw a circle. The circle will be called Mohr circle. Okay, so the graphical method to find out stresses is depends on this Mohr cycle. We first draw the Mohr cycle, and the Mohr cycle will give us the different type of stresses. Now, so that means we need to draw a circle. Now to draw a circle, we need at least 3 points. So our job is to locate the circle first. Now to locate the circle, we need diameter and center, or diameter or radius. Okay, so or center or radius. So there are different methods. There are minimum number of informations those are required to draw this Mohr cycle. So whenever we get to know that we have to draw a Mohr circle, this is the objects we need to find out. The first one is we have to present these different planes on this Mohr circle. So how to draw the Mohr circle? Here we have sigma 1 and sigma 2. We first locate the sigma 1 and sigma 2. We said that the sigma 1 and sigma 2 are normal stresses, tensile stresses, and to be taken as positive. Okay, all the stresses which are tensile stresses will be taken as positive. So from origin O, we will draw this sigma 1 and sigma 2 along same direction. So from here we will draw, say if sigma 1 is bigger than sigma 2, then it will come here, this will be value of sigma 1 from ordinate from O point to this point will be sigma 1. Now, and if we place sigma 2, it will come here, it will be sigma 2. Now, how we will draw this section? Suppose in question it is given sigma 1 is equal to say 40 MPa. Okay, sigma 2 is equal to 30 MPa. Now, in such case, how can we show this 40 MPa in this graph? So, we will write taking one smallest unit along x-axis, one smallest unit, say let 1 centimeter, 1 centimeter along the x-axis will represent 10 MPa stress. Okay, so along this x-axis 1 centimeter length will represent this 10 MPa stress. So if it is so, then we can draw, this is 10, this is 20, this is 30, this is 40. Okay, so this we have to draw 4 centimeter. We have to mark from O to here. So we will draw 4 centimeter and we will write 1 centimeter means 10 MPa, then 4 centimeter means 40 MPa. So when we write this O into A, this OA will be representing 4 centimeter, that will be representing 4 MPa stress. Okay, have you got my point? Give me a reply if you can understand or if you are having any problem. Now, so in such case, if sigma 2 is 30 MPa, then we have to draw, if we take 30 MPa, that will become very small here. So we will take here, let's say 15 MPa. Okay, for our easiness, we are changing the problem as sigma 1 value 40, sigma 2 value 15. So this 15 MPa will be represented by 15 MPa will be represented by how much centimeter? 1.5 centimeter. So we will draw from here with help of ruler, we will draw 1.5 centimeter, and this will be sigma 2. So now the coordinate of these 2 points here and here will be sigma 1 comma 0, because there is no shear stress. Here also at this point it will be sigma 2 comma 0. Now in Mohr cycle we need at least a diameter or two points on perimeter on periphery on a single dia and the center. That's what we need. Now we have to locate at least 2 points on the periphery or a dia at the periphery. 2 points of a dia on the periphery of the circle. That is what we have to find out. Now, so if we look at here, our job is to find 2 points on the periphery of the circle. Then we will be able to draw the circle. So here we have to find out the diameter. to get the diameter, we need two known planes, two different known planes. One known plane is here, this BC. This BC plane having the stresses sigma 1 and carrying this shear stress tau. Okay, so this will be the coordinate of this BC plane. Now in Mohr cycle, all the planes are actually shown by a point. So on the periphery of the Mohr circle, all the points showing any particular plane. How that will come to know. So this BC plane can be denoted in this coordinate system by the coordinate is sigma 1 comma tau, where clockwise taken positive. So if it is so, if clockwise taken positive, then from, I think the situation is getting, so we will go with an easy problem first. So we have understood that we have a cross section just like previous scenario under tensile stress sigma 1 and under compressive stress sigma 2. Sorry, both are tensile stress. This is sigma 1 and along this direction sigma 2. There is no shear stress. First we will understand this thing. Okay, so our job is to draw the Mohr circle. Our job is to draw the Mohr circle. Now to draw this Mohr circle, we need to locate a diameter. Okay, now another thing you need to know, all the points on the periphery of a circle represents a plane. Okay, which plane? Planes of different theta. So A, B, C, D, and this is CF at an angle theta. So for changing theta, we will get different planes, and those planes are actually the points on the periphery of the Mohr circle. Okay, now we draw a coordinate system. This sigma 1 and sigma 2, let us have sigma 1 is 100 MPa, sigma 2 is say 30 MPa. Our job is to find out the stresses at an angle when theta is equal to say 30 degree. Okay, this is given. We have to find the Mohr circle, and we have to find from that circle, we have to find the value of normal stress, value of shear stress, the value of resultant stress, and the angle phi, the angle which is making this resultant stress with the plane or with along the direction, with the direction of tangential stress. Let us come to the problem one by one. So this here sigma 1 is 100 MPa, sigma 2 is 10 MPa. We will take 1 centimeter is equal to 10 MPa. Then 100 MPa can be shown with a 10 centimeter line, and 30 MPa will be shown with a 3 centimeter line. Okay, just like we have learned in previous case. Is it clear up to this much? Give me a reply. Be fast. in the type section? Okay, very good. Now, so we will locate 10 centimeter from here, and we will locate 3 centimeter from here on a random. Okay, so if this is A, this is B, that means OA is 10 centimeter representing sigma 1, and OB is 3 centimeter representing sigma 2. Okay, we have located these sigma 1 and sigma 2. Now we will draw a circle. That circle is such that all the points on the periphery will give us each plane. Okay, so now if we talk about BC plane, BC plane should having the coordinate as along this direction sigma, along this direction sigma, along this direction tau. At BC plane there is no tau, so the tau value will be 0. So at BC plane the stress present is sigma 1 and tau value is 0. Okay, in AB plane, this one, no shear stress, so its coordinate will be sigma 2 comma 0, as because there is no shear stress. So these points here represented by A and B. So A point represents BC plane, and this B point represents AB plane. Okay, we will change these names so that it is easy to understand. Let us make no confusion. So BC plane can be denoted by this P point having coordinate sigma comma 0. So P point have coordinate sigma 1 comma 0. This AB plane denoted by Q point having coordinate sigma 2 comma 0, as because on these planes there is no shear stresses. For shear stresses it will have sigma 1 comma tau and sigma 2 comma tau. How they will come, we will solve on the next topic. Now we have located two planes P and Q. BC plane represented by P, which is here, and this Q point is represented by this AB plane is represented by this Q point, which is here. Now if we look on this diagram, this AB plane and BC plane making an angle 90. Okay, so here this angle between BC and AB is 90. Now here this P and Q plane at an angle with 180. So if we draw the center and take PQ as diameter, then we'll be able to draw this Mohr circle. So to draw this Mohr circle, what we are going to do, we'll take PQ as diameter, we bisect it, and from this point, from these bisected points, we make the center and we draw a circle. That will be the Mohr circle. This is how we draw the Mohr circle. Now you see this 90 degree here is 180 degree here. So whatever the angle here, and that becomes 2 theta here, keeping the direction same. So if you look here, this P means actually BC plane, Q means actually AB plane. Okay, now we have to find out, we have to look at the CF. How to find out the CF? CF is clockwise 2 theta. So this will be 2 theta. Okay, so theta is given 30. If this is 30, we have to draw here 60. So we will get the point here. Let it be E point. Okay, let it be E point. So now, if we draw a perpendicular from E point to this x-axis, it intersects here at D point. I am saying it again. Okay, remember the steps. I am repeating the steps. We take plane BC, BC plane having no shear stress, only normal stress, that is sigma 1. Tensile, tensile means positive, we have learned. So here this BC plane represented by P point having coordinate sigma 1 comma 0. Similarly AB point having no shear stress, only tensile stress, so the AB face having coordinate sigma 2 comma 0 represented by Q point. So we have located P and Q as sigma 1 comma 0, sigma 2 comma 0. How can we do that? We have the values 100 megapascal and 30 megapascal. So we have taken 1 centimeter of length representing 10 megapascal. In that case, this 100 megapascal is represented by 10 centimeter, 30 megapascal is represented by 3 centimeter. So this OQ is 3 centimeter and this OP is 10 centimeter. So we have located P and Q on this sigma and tau coordinate system. Now here this P actually BC and Q actually AB, those are having 90 here, so they are making 180 here. That means all the angles in here will represent double in this Mohr circle. So when we get 2 points on a diameter of that circle, we will draw the circle. Now from that center we make theta angle in same direction in this diagram will become 2 theta on the same direction. This was clockwise, this is also clockwise. Here the angle was theta, here angle should be d theta. Now from this point E we draw a perpendicular on OP. So in this case we will measure this OD, and this OD will give us normal stress at E, or E means which plane? Plane CF in this diagram. Okay. Now similarly DE will represent shear stress at E, or plane CF. Now if we connect this OE, we are connecting OE. OE will give us the resultant stress, and the angle phi can be found out by here. So the resultant stress making the angle phi with normal stress, and this resultant stress making the angle, so this is not phi, this is actually phi, which is making angle with this shear stress. Okay, so it depends which angle do you want. If you want angle with normal stress, it will be this angle, say this is gamma. If you want this angle, shear resultant stress with shear stress, we get phi. Okay, so which angle do you require? Depending on that, you can find out in this way. So is it clear how to draw this Mohr circle and how to find this resultant stress, normal stress and shear stress? if you measure OD is 7 centimeter, that means 1 centimeter means 10 MPa. So if OD is 7 centimeter, then you multiply it with 10 and you will get 70 MPa. So then you will write that the normal stress at plane CF will be 70 MPa. However, we will solve problems on these also, and you can also can see that this figure in last class we have found out, like this is the expression of sigma n in analytical method, and we have also found out sigma t here. We have found out sigma t also. This is the sigma t. So we can, this is sigma t and this is sigma n. We can see that when we go with this analytical method, same value, same expression will come. Both method will give us the same value, but this is very quick, easy. All you have to do is to measure these lengths and angles just accurately. And in interviews also, you will be in several cases I have seen, I have faced also, people in interview asked to draw a Mohr circle on given conditions. Mohr circle, shear stress, shear strain, shear stress bending moment diagram. Okay, these are very important. Shear stress bending moment diagram we will learn afterwards. So is it